Hey guys, what's up? Eddie Alho here with KissAnalog.com. Hey, we got a guest in the lab. Keysight. It's an oscilloscope. Now I've done one of these before. This one's different. This one's the education model, so it's pretty affordable. I'm going to pull it out of here, and this is a loaner, or is a loaner. I've got it for a couple weeks, I think, so I hope to make a couple videos, maybe even 2 or 3, and I kind of want to leave it up to you guys, what you guys think, what you want to see. But alright, so this is, it goes by the EDUX1000G, so that's the educational version. And this, it comes in 2 varieties. One with the G at the end, meaning it has a generator. One with the A, no generator. And I think the price on Amazon for the no generator versions, like just under $500 from Keysight through Amazon. Now this one with the generator is like $670, I believe. So it's around $180, $200 more. So sure, you can get a generator for less than that difference. Maybe even a arbitrary wave generator, which this is not. This is a function generator, meaning you can't create your own waveforms. It gives you your typical triangle, square, and sine, I believe. And it sweeps. So the advantage of getting the generator built into the scope is the fact that it does sweep, and the scope can control that. So as the scope's doing that, it's taking readings on this channel 1 and 2, and it can do FR8 analysis, frequency response analysis, which provides a Bode plot, which is really cool, very useful for a lot of things. If you're doing amplifiers, it can give you, gain phase of your amplifier. Speaker crossover designs, it can give you the same kind of thing. Your gain of phase, your impedance of your crossovers. If you're doing power supply design, it can do gain phase plots for your stability design. And if you're doing, and it also can do impedance curves for your power supply design, input impedance, output impedance, for EMI filters, for your power supplies, things like that. So FR8 analysis is really cool. It can do a lot of things, even things as simple and useful as looking at, say, a curve of an inductor. Okay, well, you say you could just plot that. You just 2 times pi times frequency times inductance, that's X of L. I can just plot that. Well, the thing is, though, you have parasitics, right? There's some resistance in that inductor, so you say, okay, I can do a little more math and take account for that DC resistance, DCR. Well, but there's also interwinding capacitance, the capacitor between windings. Well, yeah, I can measure that, and I can go ahead and put that in my math. Wow, you're you're kind of challenging yourself, I guess. I mean, hey, that could be fun, but that interwinding capacitance, is that evenly distributed? How does that change, like with the core material? And there's just a lot of things when you have, when you can do a Bode plot across a frequency band of interest, then that's really useful. So you can do that for your inductors, your capacitors, your resistors, individual components like that, as well as doing the full-blown filter, input impedance, output impedance, that kind of thing. So I really like the FR8 stuff. If you are comparing 2 scopes, one has the ability to do an FR8, then you may have seen some videos I've done where I've used this scope to do this kind of analysis, and I think it's very useful. Okay, so the educational version. So what comes with the educational version are some built-in waveforms. So you can monitor some waveforms, and you can practice triggering and practice capturing some of these waveforms, setting them up, and so on. And there's actually a document that you can download on the Keysight web site that's called the Educator's Resource Kit, I believe. And So basically it's, you know, an instructor or somebody taking somebody through a course and trying out the scope, trying different things. So let's just jump over here, take a closer look at this, see powered on, do a quick wave capture on using the FR8 analysis, which I think is one of the coolest things on these scopes. But, you know, so like I say, this comes in two different versions. The G model, which is the EDUX1000G generator, or the A, no generator. But, like I say, I think the generator is worth getting. You know, and there's one more thing in my other video that I showed, is when you calibrate your scope probes, this scope, I haven't seen it on another scope. Probably exists, I'm sure. I just haven't seen it before, but has a really cool way of setting up the calibration. So I'll demonstrate that as well. Alright, thanks for watching, guys. Let's come over here. Alright, so here we are, and I'm going to power it up for the first time. I mean, it's a used scope, but first time I've powered it up. So I like how bright the buttons are. Okay, they're popped up pretty quickly. Still doing self-check. And ready to go. Pretty darn fast. I'm not a, you know, unless it takes insanely long, that's not a huge deal with me, because I kind of feel like you should let these things warm up for a little while before you use them anyway. Okay, I got another light on that, so hopefully that looks better. Okay, let's get these caps off. We're going to use all these things, I think. External trigger, I won't use. External trigger, by the way, if you're trying to sync up, say, a second scope, maybe you got so many signals you've got to get another scope, or your project you're running on, you want to sync it up with your scope, you can use that trigger for those kind of things. I put the yellow color on the green and no color on this one. I don't think we're going to care too much as long as I know the difference between the scope probes. So it's interesting. We got a yellow and a purple. I'm looking the first time with you guys, so the yellow is obvious. I don't know if the purple is math, but I don't. Okay, so let's just kind of go over the outlay of the scope. Alright, what we have is channel 1, channel 2, discrete controls for each one. Turn on channel 2 as well. Okay, channel 2's right here in the green. Now, I think if I push these, well, if I move it like this, you can see green separate, but if I push it in, it locks it in the center. And yellow's off a little bit, so I think if I push it in, it locks it in the center. And by the way, this scope, like my other scopes, which is kind of a new feature for me, is I really like how when you adjust this, it pops up the little window saying right where you are. See, I'm at 0. I like that, and then it goes away. I think that's just a really cool thing. I first saw it on my Siglant scope, and then my GW Instax has it, and of course now we see it on the Keysight. So it's a pretty cool trend that they're putting in these scopes. Let me move the camera up just a little bit so we can see the top of this scope. Alright. Okay, I just wanted to make sure I had the focus set well so you can see. Now we have this signal here, which has to be a math signal, even though it must have been set up previously. There we go. Yeah. Oh yeah, okay. It showed math right here. Channel 1 plus channel 2. Alright. Yeah, so just going over the layout, we have the discrete channels here right above the probes, which is really great. The generators over here in the front, which I really like, and the external trigger up here too. So instead of being on the back of the scope like so many other scopes have, right here in front, it's got a USB for your memory stick, so you can save waveforms, download updates and things like that. Okay, then we have our trigger menu, and then in between we have this waveform. It's called FFT, math, Now often FFT is found in the math menu in other scopes, but here it has its own discrete button, which is really cool, and the reference and the wave generator. So it's a nice blue light when I turn that on. I was trying to see if this turned on a light, but oh, it's giving me a message over here. Okay, so yeah, it depends on what you have enabled, I guess. So then we have our horizontal menu up here, and then we have our measurement buttons in here. Sometimes these are swapped in scopes, but I don't mind this. This is a nice layout, I think. Big run stop button, and you know, your single button. Now what I like about this is the auto scale and the default setup buttons. They're kind of recessed just a little bit. Nice soft buttons, just like the rest of these, but they're kind of recessed so you don't accidentally hit them. So I really like that. Look, there's a little wheel for the auto scale and default setup. Now you can set the default setup, you can set that button to default the way you like, so that's nice. And the previous video I've done, I'll put the link below, because a lot of those things are the same between both scopes, so maybe that took a while to go through all those things. So I'll put the link below, and we'll kind of focus on some of the features the educational version provides. And we'll also do the FR8, just because that's something I really like doing. Okay, I think it's just a really cool feature of this scope. Now, the one thing about this scope is it has a back menu, so you can go backwards, and you know, you can go toggle through your menus, but it does not get rid of this sidebar. My Siglent doesn't either. I wish all scopes just got rid of this when you didn't want to see it. The information down here and up here should be enough, and once you've chosen what you want to do, I would just wish you could turn that off like you can on my GWN stick. Anyway, that's just one complaint I have. It's kind of a general complaint on some scopes on how they use that space on the window. Alright, so let's set up the FR8. Under this Analyze button, okay, it says Features. Here, let's select that. Okay, it has digital voltmeter and FRA. You know what? Here, let me just show you the voltmeter. That comes free with these scopes. See, it sets up a voltmeter. So that's kind of a neat thing, I guess. And we're going to turn that off and go down to Frequency Response Analyze. Okay, now we got our Boldy screen, and also it says Setup. So now this is nice. It kind of shows you what you're supposed to do. Your device under test, your scope. Channel 2 goes to V out, channel 1 goes to VN, and waveform goes to VN. So what we're going to do is we're going to look at an inductor, the impedance. So for gain, it's output divided by input. So for impedance, it's volts divided by current. So channel 1, I'm actually going to put my current probe in here. So let's get the inductor out and set it up. Okay, so going back to the setup, I've got the generator coming out of here, and it's coming out to, and it's going to connect to VN, but VN is our current probe, and V out's going to be our voltage, so it'll be voltage divided by current. So here, let me just show you how I've got that set up. Okay, if you can see that mess, that inductor, the two returns are on one lead, and the voltage probe and the generators on the other lead. And then I've got this current probe reading the current coming out of the generator into the inductor. And this is it's a Tektronix P6042. Alright, so the voltage here, the current's coming in here, and I have this 50 ohm attenuator. That's what the current probe wants. So I think we're set up. We got, let's see, start frequency 10 hertz, stop frequency 100 kilohertz, and amplitude is 9 volts peak to peak. That's the maximum the generator can put out. It's a power inductor, so I just thought we'd do that. And then output load 50 ohm, versus high impedance and points. I just got 60 points chosen because I think 60 is plenty for this kind of plot. Alright, so I think we're ready to go, and let's just run the analysis. Okay, so what's happening is the generator is beginning and the scope is setting, it's calibrating its channels and also the horizontal to get so many cycles in a screen so it can do the math properly. So we can see the waveforms, they're slightly out of phase with each other, and we can see the plots behind this. Alright, there we go. So on the blue side is the decibel scale, and on the red side is the degrees. So the red waveform started down here around 0 degrees. So at low frequency the impedance is pretty low on an inductor, and that looks to be true. It's close to minus 28 is the bottom grid, so it's minus 27 dB, and then right around 100 Hertz it starts looking like an inductor. So that looks like a pretty darn straight line. That looks like a pretty good inductor. But down below 100 Hertz it looks more like a resistor. There's not much impedance, so all you see is the resistance, the DC resistance of the coil. So the phase starts around 0 because it looks more like a resistor, and then it starts to look like an inductor, so it comes up to what should be about 90 degrees, and it looks like it goes up to about 88. So that's looking pretty good. Isn't that cool? If you don't have an inductance meter, you can use your oscilloscope to read the inductance, and you can calculate the inductance from this. You can calculate the DC resistance, the inductance. That's pretty cool. Now if we went to higher frequencies, we might be able to see, you know, what kind of capacitance it might have at the higher frequencies, but we just went to 100K in this example. Alright, so just looking at the scope, what we're going to do is I want to demonstrate the educational tools on this. But first, what I like to do is just kind of show you how, like, all these buttons are pushed to center, so they just, you know, line the, like this is the trigger. So if you have a trigger, it pushes center, and this is the cursor one. It's also got a push select to select between different cursors, and the horizontal has a push to select, so it puts that arrow right there in the center. So if I put it off a little bit and I say push to center, it centers it. And if the trigger is on here, this trigger would set up in the center too, pushing this. So you know, the entry mode here, this is kind of the general purpose knob, and it has a push to center. So they all have push to centers, which is really nice. Alright, so now let's get to the kind of the cool part of this scope. Now, alright, so let me point out a couple more things I like about this scope. Is it has a wave generator, that's neat, but it has these on the trigger. It has the force button, which is nice. Some scopes don't have that. It has to push to 50%, which is nice, which I already kind of talked about. But it has a save to USB, so when you want to save an image or something, you have something plugged in your USB, just push that. So it's got a nice little button. You don't have to go through menus. It has a quick action button, which you can assign to whatever you like. And it has a default setup, which you can assign that one to. And then it has an auto scale. Again, these are kind of, you know, indented, so you can't, makes it a little harder to accidentally hit them. I remember some of the scopes earlier would have the auto scale right next to the run stop, and you'd kind of, you know, be looking at the screen and go up to hit the button, and you'd actually hit the auto scale. That was always kind of frustrating. So that's why they kind of inset these and put them off to the side like that. So it's got, you know, so that's kind of neat that it has these discrete buttons around here, like the FFT one, for instance. That's another discrete button. The one for bus, if you've got digital signals. So that makes this scope pretty easy to see, because some of the common buttons they've provided, so you don't have to dig through menus. And really nice. Okay, so now what I want to show you is they also have a help button. And when you hit the help, you can go through and do things. Now, by the way, before I show you that, if you're looking at, say, the FFT, for instance, if you just hold that down, it'll come up with the help menu. Okay, so there's that kind of help too. So that's what I really like. So when you're going to use, say, a trigger button, you push trigger, well, it kind of shows you your trigger types. You can see all this stuff. But if you really want to know what that is, you can just hold it down and it comes up and tells you. So anywhere along the way, I think you can hold about any button down and it'll tell you what it is. So this help button kind of goes through some menus if you want to, but it also has this training signal, and that's what I wanted to show on this scope, the EDU. That's what makes this scope special. So you can hit training signals, and then it says to hook up your scope to this. See, it's called probe comp, but it's also called demo. So that's kind of the magic on this scope, kind of educational purposes. Now I still have the FFT, so I'm going to turn that off. Okay, and then we'll just turn on channel 1, and I'll hook this up to that. And see, we already have the ground connected, but this just kind of helps maybe provide a little quieter signal with the coax here. And I think we're going to be at times 10. Now see the trigger and this trigger position, if I push it, now that I have a signal, it does something. It puts it right in the center. And you can see the number 1, so it says channel number 1, it shows little ground symbols, so that's the reference. But look at that. It doesn't look like it's been compensated, but this is where I want to show you something else really cool about this scope. So you push the probe, and then you say probe check. And then it tells you to hook up your probe to the compensation jack like we have it, and then to push this. So I do. Little busy wheel there. Now look at this. It's actually telling you how to compensate it. So it does this part even in the scopes that are not the educational versions. So this is just kind of a cool thing that they do. So okay, I'll just push this in here, and wow, okay, I think I hit it right there. So I'll just say okay. What it does is it checks to see if I did a good job. So it says probe check passed. So I guess I did all right. So that was pretty easy. Okay, so now that we're here, we go back to the help menu, and then we hit training signals. We've done that, so we say that's good. So we hit this button, and look at that. We've got all these training signals built into the unit. RS-232, digital burst. I mean, you can see there's a lot of signals here. So what I want you guys to do is let me know what you want me to show you on the scope, whether it's FFT or one of these training signals. You know, if there's some things you want to do, I can pick a few things, I think, and we'll try to go through some of these on another video. So for now, I think I'll just pick, what do I want to pick? I'm going to pick this RF burst. Okay, it says demo mode, default to exit. So there we go. Now I can play around with the scope to see if I can figure out how to get that. One thing I think I can also do is maybe just do this auto scale. Okay, it shows me that. So now that was kind of, you know, cheating a little bit just to do it, but now I can go to this scale here so we can zoom in that way. I can move around, center it in the middle of the screen, but I can also zoom out to see if I got other ones. Look at that, there's more. So that's what you always want to do. You want to kind of look at the bird's eye view, like right there, and then you want to zoom in and see what's going on. So by the way, so let's just do that. See, here's 3 of them. Now if I have too many of them, I just want to point something out. See how it's doing this? That's one of the things with the scope. It doesn't have a lot of deep memory. So when you get too many pulses, you're going to have some issues like that. There's some ways to get around that, but for now, let's just do this. There's 3 signals, and let's hit this magnifying glass. Now see how it's grayed out? So now all we're seeing is what's in that little section right there. So I can come up here and zoom out, open up that little window. See that little window? I've captured this guy. Okay, maybe I think that one of these guys are more interesting. I want to zoom over there. So I can move this over. Now the fastest way to move it over is to actually zoom out a little bit and then come over and try to center it. And then move in. And then once you have it in the center of the screen, once you have it in the center of the screen, then when you zoom in, it kind of holds it there. It zooms to the center. So, and that's the way where we can just zoom in on the signal like that. Now, see where the trigger is? It's right here in the center. You can see the little T over here, maybe, hopefully. And up in this window, you can kind of see where I'm moving it based on this signal. So here, I'll move it around so you can watch it. See, when I go above the signal, then it's not capturing anything. So I have to bring it down, and I might want to be looking for the highest peak signal. If there is one, it'll trigger on it. So I keep bringing it down until it triggers, then I know I've caught the tallest, essentially the tallest pole in the tent. So, right, yeah, it's, and see, it's going to capture it right there, which is in the center of my window. So it looks like, there we go. We got it. So then I can move this over like that. I can zoom back out. And now see what I can do is I can push to center this. Oh, it gives me the fine or the coarse is what that does. That changes that to fine and coarse. So yeah, there's also, see how I can move this really in finer detail, and then coarse. So that's how I can kind of zoom in like that. So that's what that allows me. And then coarse adjustment, bigger notches when I move it. So fine, I can zoom in, kind of fill in the window. And then this guy, push to center, that put it right here in the center. So alright, just wanted to show you these training signals and how neat that is. Alright guys, so I hope that was kind of a neat thing. You can see how small it is. Here, let me just move the scope around so I can show you what it looks like up close. And one thing, you can see this, whoops, okay, let me zoom out, and you can see this handle on top. It snaps into place. You can see the feet on the bottom that kind of snap into place. You know, pretty basic stuff. There's some vents down here. This scope is heavy, by the way. It's kind of girthy, and you can see I can feel the air coming out of that, it feels like. So it's coming out of this, and it looks like there's a place for a strap here, and on the back it's the sucking air into it here. And then we have our a place to hook up devices to power differential probes or whatever. So, and then our rubber feet, which, you know, help when you're sitting up on the corner to keep from skidding. So yeah, and then these indents kind of help hold the scope when you're moving it around. But this is a pretty heavy scope, I'll tell you, especially for how small it is. I've been hitting buttons as I moved it around. Alright, so pretty cool scope. Okay, so these are the scopes in this series, and you can see the specs here, and the one we were just looking at is this guy here. 50,000 waveforms, refresh rate for all of them, 1 gig samples, more than plenty, sufficient for 50 meg scope for sure, and 100K points, so that's kind of on the small side as far as deep memory goes. 2 channels, 50 meg. So that was the scope we were just looking at. And this is the educator's training kit that I was talking about. So you can download that and take a look at it if you like, and give me an idea of what you'd like to see. And this is the educational versions. The G is the generator, A is no generator, and so you can kind of see the 7-inch display, and there's another spec sheet. And this is how it compares to the Tektronix TBS1000B Education Series. You can see how they compare right there. The Keysight looks like it beats it in just about every category. Now, just to show you sheet 2 of this, it's just some more information about the Keysight scope. They like to call this 6 instruments in one because you get the oscilloscope, you get the frequency response analyzer, the Bode plot, which I think is really cool, the wave gen, serial protocol, the digital voltmeter, and the frequency counter. So really, the thing that differs in this scope from most, from a lot of scopes is the FR8, the Bode plot. Alright, and to compare it to the Rigol 1000Z series, this Rigol has had a lot of airtime, and you can kind of see how they compare. Again, the Keysight beats it in every category just about. Hey, so what do you think, guys? Pretty cool scope. If you're trying to learn electronics and you want to go through these educational programs that they have built into the thing, if you want to just practice with some of these signals, it's pretty cool they have all these things built into this. So I think that's a pretty cool scope, and I just wanted to show it to you. It's called the EDUX1002G. So pretty cool. I want to thank Keysight for letting me get my hands on playing with this thing. And so what I was kind of hoping to make this video somewhat short enough to not spend a lot of time going into things you're not interested in, and that you could get a good look at what scope offers and what it looks like. But at the same time, if you guys want me to do another video demonstrating some of these educational things, or FFT or some other feature or function of the scope, if you want me to walk through some things, let me know in the comments, alright? And see if you guys want another video on the scope. Thanks, guys. Thanks for watching. Thumbs up, subscribe if you haven't yet. I appreciate that. And we'll see you next time.